Last example here, we want to, again, find the amplitude period and the equation or function that models this curve. So this one's a little bit more complicated than the others. Again, your standard sine and cosine functions. So sine starts at 0, increases to a high point, goes down below the x-axis, and then goes to a low point and comes back up. Cosine starts at a high, goes down, comes back up. Looking at this graph, I like that the graph goes through the origin right there, but it doesn't, model either one of the graphs, right? The sine graph starts by going up and then comes back down. So in my opinion here, this, resembles a sine function, but to me it looks like it's inverted, right? So that means, we're still going to work with a sine graph, right? But it looks like it's inverted, so I'm going to make note of that. Which basically is going to tell me that my A is going to be less than 0, negative, right? Because it's inverted. So that's critical, right? So now I'm going to deal with the sine function, and now I have to find the period, okay? The period, it can be calculated several different ways. Again, critical values are your key. From what we did in the last few examples, we found high points and measured the period from those high points. So each one of these tick marks on the x-axis is 1 unit. So that's going to travel from -1 here to +3 here, right? Giving me a period of 4 radians, right? So that's my period. Alternatively, you can measure the period from any 2 points, right? So if you really wanted to, you could measure the period from this point and that point, still 4 radians. You could measure the period from this point and that point, still 4 radians, okay? I like to try to measure it from points that are kind of away from the graph. That's why I chose the high points here, the maximums, but you could use the minimums, or you could use points on the x-axis. Doesn't really matter. What matters now is what's the amplitude, right? So my period is 4 radians. Okay, the amplitude again is the measurement from the maximum value or the minimum value to the line of oscillation. So that's 1, 2. It's 2 units there. So the amplitude is 2, +2, right? So I'm going to note that. Amplitude is always positive, but because we said that this graph was inverted right here, right, that means my A value is negative. So my A value is going to be -2. Okay. I am using the sine function, so I have to model this. Y equals A sine of Bx. Right, I have my A value. I need to find my B value. I have my period. Remember, period times angular frequency is always 2 pi radians. So my period is 4. My angular frequency is unknown. I'm going to divide both sides by 4 and get an angular frequency of 2 pi over 4, or just pi over 2 radians. Now I have my angular frequency. And remember what I said in the last 2 videos. If your x-axis here is in radians but not in terms of pi, then your angular frequency will be in terms of pi, and vice versa. If your input axis here is in terms of pi, then your angular frequency will not be in terms of pi, right? They're just kind of reversed. Now that I have an amplitude A and my angular frequency, I can write my equation. Y is equal to -2 sine of pi over 2 x. That is a function equation that models that curve there. So tonight your assignment is to kind of work on some of these graphs. And then tomorrow we'll pick up and start solving more complicated trig equations.